So, something I talked about a little bit. So, an atom can be described by L vector, the total orbital angular momentum. Now remember, I can only get the magnitude and the z component of that. I can't get x, y, and z of the vector. S, the total spin angular momentum. And remember, each electron is spin 1/2. So S is 1/2, it's Sz that can be plus or minus 1/2, z component. And finally, J, which is the vector sum of L plus S. So that's where we're at with this. So now, how am I going to do this vector sum? What I want to talk about briefly is, and I think I might have some videos on this. I should go back and dig out maybe post. Addition of angular momentum. So given a J1 and J2, J is a term we often use for just generic angular momentum. So given any angular momentum, be it spin, orbit, nuclear, what have you, the possibilities and I'm going to say, so there's J1 and J2, and with quantum numbers, J1 and J2. So these are scalars, J1 and J2. Okay. The possibilities for sum for the sum, the vector sum, are J3 is going to be, this is a member of the set, isn't it? The designation, I think. Absolute value of J1 minus J2. Absolute value of J1 minus J2 plus 1 on up to J1 plus J2 plus, no, minus 1, I'm sorry, and J1 plus J2. Let me take a real quick example. That looks a lot more complicated than it is. Suppose I have a L equals 1 and a S equals 1/2. How can I put these? I can put these together. I have a J goes from L minus S to L plus S in intervals of 1. That's just what I did here, which is this here. Okay. So what are my possibilities? I can have J equal to L minus S equal to 1/2, or J equal to L plus S equal to 3/2. How does that work? Vector sum. So let's do the 1/2. I'm going to go like this, and then like this. And what do I have left? That's my net vector. Or I can add them. And the angles, I'm not doing the angles quite correctly, and now I have, so what do I have? This is j equals 1/2, and j equals 3/2.